To learn about the phases of testing. So in the STLC, we have seen so many steps, starting from test planning to creating test cases, and then setting up the environment and executing the test cases. You have to follow some phases of the testing steps. So there are 4 major phases of testing. We'll learn about them today. So let's proceed with the class going on. So first phase of testing is unit testing. Now, before I explain anything about any of the phases, let me show you a quick diagram which will make it very clear. So here we go. So here you can see all the phases of testing listed down. First is unit testing. After unit testing is over, what is unit testing? We'll quickly walk you through. So there are different modules which all the developers are working upon. So each developer is doing testing on their individual modules, so which is called unit testing. So each unit is being tested. So unit testing is done by the developers. So when all the individuals modules are tested individually by all the people working in the team, later on they are collated and they are integrated together and sent to the QA team for doing further integration testing. So that is integration, wherein we are getting modules combined which have been already unit tested, and then we'll perform integration testing onto them. And then later on, when all the integrated modules are there with the QA team, we'll collate everything together. We'll install it onto a system for which the software has been meant, and later there will be a full system testing done on the software. So that is the system testing phase, wherein all the individual modules were combined, all the integrated modules were combined together, installed on a software system, and then we are doing on the simulated environment, we are doing a system testing altogether. And then later on, after the system testing is passed, there's a go ahead from the system testing team. We will perform UAT, which is user acceptance testing. There are 2 phases of UAT, again alpha and beta. So we have already discussed about UAT testing in a separate video, but you have to know again that okay, there is an alpha testing and there's a beta testing done, and finally when both the alpha and beta testing is passed, we say that yes, UAT go ahead is there. Then we can perform and do a production release. So there is a production deployment, and the final software is onto the production server. So these are the phases of testing which any software will go through. So we have to know and understand each one of them. So today we'll be discussing on unit and integration and system testing. So let's move forward with the session and let's see what we have in today's PPTs. Now, unit testing, as the name suggests, its unit is the smallest testable piece. Okay. So to explain this also, I'll show you a quick diagram. But before that, let me just walk you through the definition at least. So here the developer who is working on that particular module will be doing some testing so that the defects which might go forward in the system can be caught at an early stage, and at the same time he is well aware that his own code or piece of code or unit is working perfectly fine or not. So unit testing, a unit is the smallest testable entity of the software. It is tested by the developer who is creating it, and it will be sent forward. So what is the requirements? It requires knowledge of the internal programming logic and the design and the code, of course, because the developer himself is doing it, and at the same time unit testing requires the internal coding knowledge for it to be performed. It is done by the programmers, already discussed. Unit testing of a software application is done during the development phase. So yes, while the code is being developed, the developers, after developing them, does unit testing on the piece of code. So it is during the development itself, right? Now we'll talk about what are the objectives and why unit testing is important. So if you go by each pointer, so of course, to test the function of a program and unit of code such as programs or modules. So whenever there is a piece of code which is written, it will have individual functions and modules inside it. So we have to make sure that each function, each module is tested well. Unit testing will be helpful in testing the logics which are written inside the code so that any software planning or the requirements which are decided based on a particular algorithm should not be working wrong. So this testing is important so that whatever requirements have come, whatever logics have been applied, is actually working exactly in the same manner. So the test internal logics, yes, to verify the internal designing, yes, because whenever a code will be written, it's very important that the entire code is properly tested and the internal designing is fine. There is no issues on the software UI. So we have to test that. To test the path and the conditions coverage. So in any code there will be conditional statements, there will be loops which will be applied. So unit testing will make sure that all the conditions which we have applied is actually working as per the requirements. So let's say we have applied a conditional loop and we have written a piece of code which in turn is leading us to an infinite loop, or maybe which in turn is not giving us the exact result set which we wanted. So a unit testing will be helpful in finding those errors out in the initial phase of the development, because if there is any issue related to the conditions which we have applied as per the logics or the algorithm which have been thought about, and the code breaks and the system is not performing as per the requirements, so there is no point moving further with the development of the software. We have to first get it fixed and then create another module and then integrate it, because if this particular piece of code will have issues still, if there are still issues in the code, if the logics are not working fine, and if we create something else and integrate it together, so this issue will be causing the entire system to not work in the proper manner, and later on, even if we resolve it, we have to do a lot of more testing to see that this issue has not affected the other part of the already created software. So to avoid the downward flow of defects, very important, unit testing helps us avoid the downward flow of defects. In testing, I have said that we have to make sure that the errors and the issues or bugs have to be caught ASAP in the system in the earliest possible time, because more the issues or more the time the error stays in the system, it affects the larger section of the software. So where that wastes or that involves a lot of testing and lot of resources are involved in finding issues out if the system becomes larger and this issue still prevails, because earlier we find out the issue, earlier we remove it from the system, there are less chances of bugs spreading onto the entire system, because one function can lead to another functionality, and it can be so much linked and associated that a lot of testing might be required later on, and it involves a lot of time. So you have to test all those in the beginning as unit testing. Test case written after, yes, so the test cases are actually written after the coding is over for unit testing. So unit testing is the first testing which happens on the software, on the piece of the software which is created by the developers. It is very important so that the initial issues or the logics in the issues in the logics or the internal coding or the conditions which or the path or navigations which have been applied on the code is working perfectly fine. There is less downward flow of the defect. The individual developers who are working on the software will be more aware of what they have coded, and they can do testing easily, because they have just written the code and now they can just test it and then move forward with any further development, because that's how the system will be towards a perfect development. If we skip unit testing and we create a lot of code and then later on we'll do testing, so that creates a lot of mess and there is a lot of downward flow of defects. There's a lot of spread of the defects throughout the system. So we have to make sure that we are actually coding and unit testing it in the very beginning, and as we are coding we should keep testing it so that there are less issues in the system. So that's about unit testing, guys. We'll move forward and we learn the next phase of testing, which is integration testing. Now, to make you understand what integration testing is, I'll quickly show you a diagram so that we get an idea on how unit integration system and UAT testing work. And then we'll come back to the PPT again and then we'll continue. Now, if you can see my screen, there are 4 different servers on my screen. First one is development server, on to which many developers are working. They are D1, D2, D3, D4, D5 and so on. And then comes the QA server, which you can see there are different QAs who are working on the system, QA1, QA2. And then we have a different server called UAT, and then the production server. So let's say you're working on Amazon, so your dev server URL might look like dev.amazon.com. It's not mandatory, but just to make or distinguish between the different URLs and the servers, I have used these terms. So dev.amazon.com is your dev URL, and qa.amazon.com is your QA URL, and uat.amazon.com is your UAT URL, and of course the final production URL is your www.amazon.com. Now, this guy, developer 1, he is coding his piece. Let's say he's working on the registration module of the Amazon.com website. So the registration module is complete. He'll do unit testing on his own module. Developer 2, he's working on the login module. So this guy will code the login module. He'll do unit testing on the login module. Then there is developer 3. So this guy will again, so after the developer 3 will probably work on the dashboard or the home page, and he'll develop the home page and do unit testing and then push his code into the dev. So everybody is pushing in his code to the dev server once they are done with the testing and of course development and testing. So now unit testing is done for this, unit testing is done for this, unit testing is done for this. So all the 3 modules are unit tested. Now probably there can be a combination of these modules and they'll be sent to the QA server for doing an integration testing. So we have 3 modules with the QA team now, which are the registration page plus login page plus the home page. So now QA team can have some work and they can start on to the testing. So this testing, wherein the QA team is actually testing integrated pieces of code, is called integration testing. So this is the diagram which I had to show for how the integration testing work. Let's say this developer 4, he is the D3. Let's say the D4 guy, he is working on cart module, let's say. So cart module is ready. He'll be unit testing it, of course. So unit testing done, and then there will be a combination of these 4 modules again, and it will push again for second build. This is build 1. This is version 1.0. And then the second software is version 1.1. It has come for testing. This is our second build, which has come with the cart page, of course. So now we'll be doing integration testing onto that, and it will keep on, it will go on and on until the entire software is ready. And after the software is completely, all the codes are integrated together, they will deploy it onto a simulated environment, and we'll do a system testing onto it. Now, let's go back to the PPT and understand about the technicalities of integration testing. So we have different techniques to perform integration testing. So we'll learn about that also. But this diagram is very important, guys. As you can see, there is a dev server. There is a dev server where developers are working. And after their integrations are done, they are pushing the codes to the QA server. Once there is integration and system testing all over onto the QA server, everything is working fine, there will be a push onto the UAT server. So UAT testing happens only after the system testing is completely passed. And once the UAT testing, alpha and beta testing is checked, yes, true, it's passed, then there is a production release onto the production server, which is www. So that's how it works. So we'll now focus on the integration testing, and I'll go back to the PPT. Which have been integrated together, and we have to check that the if individual modules were working fine, so now after integration, are they working perfectly fine, or is the integration successful, and at the same time whatever the code is meant to do, is it doing it well? So there's a lot of questions and there are a lot of answers which are expected as a part of the integration testing, because this is the first testing which the QA team is performing, and they have to be very sure on whether the code or the builds which have come is working fine or not. So there are different methods of performing integration testing. We'll talk about it, but for now we have to understand what is the definition, how it is performed. So modules are being coded by different people. Yes, of course, there are so many developers in the team, so they are doing their own piece of unit testing on the individual modules they have created. Now later on they'll combine the modules, they'll send it to the QA team. So these are being performed by different developers. So we have to check that the integration, because developer 1 has coded something and developer 2, so we are combining, so they should be in the same sync and they should be working perfectly fine. So it's important to do integration testing, isn't it? Who is doing? The testers are doing, of course, developers are doing the unit testing, the testers are doing the integration testing. And test cases are written when detailed specification is ready. Yes, so we can only create integration test cases once we have the low level design specifications, proper functional specifications are ready with us, because integration testing is a very in-depth testing which needs a lot of understanding of the software we are going to test on. So test continues throughout the project. Yes, because in integration testing we are testing it until all the modules are complete, isn't it? So every time we are getting a new build, there is a new integration happening, so it continues until the project ends, and at the end we have to combine everything together, do a deployment on a simulated environment and do a system testing. That is a different testing altogether, but we have to understand that yes, this test continues throughout, isn't it? So it's where it is done, programmer's workbench or the tester's workbench. So why it is done? To find out if there is any inconsistency in the combination of the units. Now there are some needs which we have to understand. Why do we need to perform integration testing? So since each module is designed by different individuals, as I said, so their integrations, after integration, they might not function in the same manner. So we have to be sure on that, and we have to test it, of course, and we have to do integration testing in a way so that we are able to locate the errors. When we are finding any issues, we should be able to locate from where the issue is coming, right? So do a backtrack of issues, find out where it is coming from, if that particular issue has affected any other section of the code or not. So now, what are the needs of integration testing? So we have to understand why do we actually need to perform integration testing. So as I said, that different modules are developed by different individuals. They have their own style of coding, and everybody will have their own logics of own way of applying the logics. So to make sure that the integration of the modules are perfect and is working as per the requirements is important. So this integration will be done and will be tested to make sure it is working fine. Now, when the module is developed by the coders, so there are a lot of chances and there are a lot of situations where there are changes made by the clients. So these changes have to be incorporated at certain sections of the software. So integration testing is important to check that if there is a change request from the client, or if there is any changes which have been made to the software. So these changes have affected a lot of sections, and also these changes are required at a lot of sections. So to be sure that they all have been done in a proper way and at proper places, it is important to do testing on the entire integration. So that is yet another reason and need of doing integration testing, because we have to be sure that any changes which have been incorporated in the system is actually made at the right locations, right places, and also these changes have not affected the other part of the software. Now, so new changes which are coming, they might not be unit tested also, because they need to be changed and integrated quickly. So if there is no unit testing, probably, let's say, so we have to do integration testing altogether. So that's the also reasons. Now, other reasons or other needs of integration: external hardware interfaces. So any external hardwares which are getting integrated as a part of the software changes or software requirements, they can be erroneous. So we have to make sure that this integration testing is testing everything in and out, and everything is working perfectly fine. Exception handling: if there is less exception handlings done, or maybe there's inadequate amount of handling done, and we are not getting enough error messages, or if we are not able to handle the unexpected situations, so integration testing will help us find those, and we'll have proper remedial actions done on any exceptions which might occur, isn't it? Now, if we talk about the approaches and methodologies of integration testing, there are majorly two methodologies of performing integration testing. What are they? The one is Big Bang approach, and the second is incremental approach. So these are the methods or techniques by which we can perform integration testing. Big Bang approach is a method, is a way in which we have to wait for all the modules to be developed, and then the integration is performed, and then we do the testing. So that is a Big Bang approach. Now, there is another kind of method which can be used to perform integration testing, which is better than Big Bang, is incremental approach. Now, in incremental, there are three subtypes. So the first one within incremental approach is top to down approach. The second is bottom to up approach, and the third one is sandwich approach. What is top to down approach? Here, the top modules are developed first and they're tested first, and then the lower modules. So I'll explain this with an example to make it more clear, but just to define it here quickly. So we are doing a testing of integration of the modules, and top modules are tested first, and the later on modules, and the lower modules later on. And then vice versa, there is bottom to up approach, wherein the modules which are at the bottom of the hierarchy is being tested first, and the upper modules later on. So how do we do this? And sandwich is, of course, the combination of both the approaches. Of course, incremental approach is better than Big Bang, because in Big Bang you have to wait for all the modules to get ready, and then you can only test, which is as good as doing system testing altogether. Or maybe it's not a good approach, because it is very difficult to localize the error or where the fault is coming from. So it's very difficult to point out the sections or the areas of the bugs from where they're coming. So better approach is, of course, incremental, wherein we are as the system is being developed, as there is development, and then we are doing the testing as and when. So if we are developing it, we are doing the testing, integrating it, doing the testing, further development, integration, doing the testing, and so on. So there is an incremental testing which is happening on and on. But in the other approach, which was Big Bang, we had to wait for all the modules to get ready, and then we'll do the testing. So no, that is not a better approach. The better amongst the two is incremental approach. One is top to down, one is bottom to up, and the last one is sandwiched approach. So we'll talk about all the three. Here what is happening, all the components are getting developed, and then there is an integration done. Now advantages is that it is convenient for smaller system, because if there is a small system, we can just wait for all the systems to get coded and then unit testing done, and then we'll do a combination quickly, and then we'll do a full integration testing. But if the system is large, it's not feasible, isn't it? Because if the system is huge and we are waiting for all the modules to get unit tested, and then we'll combine, and then we'll do the testing, it's not a good idea, because if then we are finding the issues, it's very difficult to locate from which section this issue is coming, and how do we resolve it, where all we resolve it. So It is only good for smaller systems if at all we are doing it. Disadvantage is, yes, if even if in a small or large system, wherever you're getting issues in case of this approach, it is very difficult to localize it, like where the fault is coming from, to find out the area of the fault. So yes, fault localization is difficult. Okay, so if there are so many integrations happening together, there can be a possibility that we miss testing some sections and we miss issues. So leakage can be there. Defect leakage can be there in this kind of approach. So yes, because the testing team will come into the picture only after all the modules are developed and unit tested. So testing team will have very less action to be done in this approach. We have to wait till all the modules are developed. So testing team will have very less work till everything is unit tested and integrated. Now, so if all the modules are tested at once, so there is a high risk and there is a possibility that we can not decide on the priorities. There can be issues which needs to be tested before and there has to be a priority which has to be fixed. So there's a possibility that we are not able to fix the priorities, and there are chances that major issues, critical issues are missed, and we are only able to find out smaller issues, trivial issues. So Big Bang approach is not a great idea for a large system. So that's about the Big Bang approach, wherein we are combining everything on the same, we are waiting till everything to get developed and unit tested and then combining. Now we will talk about incremental approach. So here what we are doing, we are testing the units as and when they are getting developed. So we are developing a module, doing unit testing. We are waiting for the next module to be developed, unit tested, integrated together, sent for testing. So we are doing testing, ongoing testing as the system is being developed as well. So here all the modules, 2 or more modules who are logically related to each other, of course. So each are related to each other. So we are combining them and doing the testing. So there is 2 terms which will come into picture in this approach. One is stub and one is driver. So these are dummy programs. What are stubs and drivers? So when our entire code or entire software is not ready and we have to do testing before anything is ready, before any function or program which we need is ready, and we have to do testing for the further modules, let's say. So we need dummy programs or logics which actually act as the module which is not ready. So they are called stubs and drivers. So I'll give you an example to make you understand this, so that it's very easy. Stubs and drivers do not implement the entire programming logic, but they actually perform the logic or the function for which we are actually calling them. So I'll give you an example of that. Anyways, stub, it is called by the module under test. So if we are testing one module and we need some other modules, so stub will be called. And driver is the module who will be calling the modules which has to be tested. So as we have seen that the incremental approach are of 2 types. One is the top to down approach and the other one is bottom to up approach. So these are carried out by 2 different programs. One is called stub and the other one is driver. Now what is the difference between stub and driver? We'll understand this, but before moving on with the difference, we have to take an example which will make it very clear between the difference of top to down approach and bottom to up approach. Now we'll come back to the slide later on. So first let's see what is top to down approach of integration testing. In the top to down approach, the top modules, the crucial modules are tested first, and we then go towards the lower modules. Now here what happens, it might be possible that the initial modules are ready with us and the lower modules are not ready with us. So in that case, we use a program which is called stub. Stub are usually called the called programs. So the lower modules which are not ready with us are actually called. So what are these programs? What are stubs? They are programs which act as the lower modules. They are not yet ready, but they will be performing the functions for which they have been written. So taking an example, let's see this diagram. This will make it very clear. So we have a diagram here. So let's imagine that this is a banking application wherein we have the login page in the initial as the top module. So first a person needs to log into its bank account, and then there are two separate modules beyond that. One is send money, the other is view balance. So after the person logs in, a person can either view balance or the person can either send money to any of his pays. Now in the view balance, there is further submodules. Let's say it is download statement. After login, let's say there are two more modules. One is view balance and the other one is send money. So in the further modules, submodules of view balance is download the statements. So it can be the bank statements which needs to be downloaded. So it is one of the lower modules of the view balance main module. Here in the send money module, there are further submodules. One can be we have to first add the pay, and the second module can be imagined as remove pay. So let's imagine this is one of the banking application flow. Now let's say we are trying to test. So we are onto the login module. We have the login module ready. We have already tested it. Now we want to see and test the send money also. So we have the send money ready with us, but we don't have add pay module still ready with us. There can be a situation like that where in the integration testing we do have the higher modules ready, but the lower modules are not yet ready. So what to do in that case? Because we have to test, we need to do the integration testing. So this is one of the approaches which is called top to down approach, in which we have the higher modules ready with us, but the lower modules are not ready with us. So the arrow which flows from top to down. So the down modules like the add pay or the remove pay modules will be catered by programs called stubs. So what are these programs? These are written codes which will actually do the work of the add pay module and the remove pay module, but they're not yet ready. We don't have the UI ready, we don't have the application yet ready, but the programs which are there will be acting as the add pay, will be serving or catering to the requirements of the add pay module. So what we do, we log in, we use the send money, we test the send money module also, but now we want to see that after sending the so for sending the money we have to add the pay. So we need this module which is not yet ready with us. So what to do? We'll be using something called stubs which will act as the add pay modules. So this is called top to down approach, wherein we have higher modules ready, we don't have the lower modules with us. So what we do, we use some programs called stub which will act as the or which will fulfill the necessity of the lower modules. Now vice versa, there is yet another way of testing or doing integration testing which is called bottom to up approach. So this is just the opposite case of top to down approach, but there we don't call the programs as stubs, there they are called as drivers. So we'll see why they are called drivers and not stubs, and how stubs are different from drivers. So I'll open another diagram for bottom to up approach. So here we go. So this is bottom to up approach. In this module, what happens? We have the lower modules ready with us, but somehow the higher modules are not yet ready. They are not yet developed. So what do we do? How do we test? So let's say add pay module is ready, remove pay module is ready, but we want to test send money application. That is, after adding pay, are we able to send money? Or maybe login. So we want to see that a person is able to add pay, but for that we need to log in first, isn't it? So how do we do that? So we do it using programs called drivers. So this is exact vice versa case of top to down approach, wherein we do have the lower modules ready with us, but we want to actually test the functionality flow. For that we need the higher modules, of course. So this is how it is different. It is called drivers here. They are the calling programs. So stubs are the called programs and drivers are the calling programs. We'll also see some more differences between stubs and drivers in our next slide. But for now, we have to understand this diagram and the definition of top to down approach and bottom to up approach, wherein they are two different, entirely opposite cases, but both are used for doing integration testing And have we known so far about integration testing? That it is a testing which will happen after the unit testing. So we'll have all the unit modules tested by all the developers of the company. Now, they are integrating the codes as and when they are developing it and sending it to the QA server for testing. So we have the integrated module and we are doing the testing. So we are applying different approaches. So we came to know that yes, we had two major different approaches of doing integration testing. One was Big Bang approach, where we were waiting for all the modules to get ready. We were integrating them together and then doing the testing. But better way of doing it was incremental approach, wherein we had two ways of doing it. One was top to down, other one was bottom to up, and of course sandwich approach was also there, which is a hybrid of top to down and bottom to up. But majorly we'll be using one of the tools, which is top to down and bottom to up. So herein we are using two programs, stubs and drivers, and they are helping us do this testing, where in top to down we are having the higher modules ready with us. We don't have the lower modules ready. So what we do, we use programs which are called stubs. They'll be helping us act as the lower modules, and they'll helping us perform the actions of the lower modules, and we'll be able to do the testing. Similarly, in the bottom to up approach, and we'll come back to this, we have lower modules ready. We don't have the higher modules yet ready. So we will use drivers who will actually act as the higher modules and help us do the entire integration testing. Now, going back to advantages and disadvantages of top to down approach. So advantages are, of course, our fault localization is easy. Yes. If we know how and when we are testing, if we know the flow, it will be very easy to understand from where the bug has come. So to locate the bug, it will be easy. So fault localization is easier in case of these approaches. We have a possibility to obtain an early prototype. Why? Because we already have the higher modules ready and we are already using something called stub. So we can get a prototype of how it will look like. So once we have the software ready, even before that, we can show the prototype and we can imagine and show that how our software will look like. So early prototype is ready in that case. Of course, here the critical modules are tested first. So if the critical modules are tested way ahead of minor modules or lower modules, it's the probability of finding critical issues and getting them resolved is fixed here. So that's how we are able to have a better testing system, wherein we are able to test the critical modules ahead of lower modules. What are the disadvantages of top to down approach? There may be a possibility where we need a lot of stubs, because we have the higher modules ready and we don't have the lower modules. So there can be a possibility wherein we need many modules to perform the testing. So there can be that possibility wherein we can require a lot of stubs. Also, if we just add on to this disadvantage, we can say that yes, the lower modules are tested inadequately because we have put in enough of our efforts and time on the higher modules, and since we are using stubs for catering to their requirements, and later on when the lower modules will be created, we might not have enough time, and there can be a possibility that they are tested inadequately. But it's not a major disadvantage as such, it is just a probability. So going back to bottom to up integration testing, and we'll also see advantages and disadvantages of it. So the advantage remains same, that yes, fault localization is here also easier because it's a similar approach. Here no time is wasted for the modules to be developed, unlike the Big Bang that is certainly the advantage with all the incremental approaches. We don't need to wait for all the modules to get ready. Like in Big Bang approach, we were waiting for the entire set of modules to be ready, only then we were doing the testing. So this is an advantage for both or all the integration testing of the type incremental approach. Now disadvantage, if we say, so critical modules are which are more prone to defects are tested later on in the process. So that can be a certain disadvantage because they are more critical. And on the top, here early prototyping won't be possible because we are not yet ready with the higher set of modules. So how will we create a prototype of it? So that's the whole logic behind the difference of the two. Now let's see the difference between stub and driver, which we have seen as the programs which are used for the incremental approach integration testing. Now stubs are the call programs. These are the programs which act as the lower level modules, and they help us do the top to down approach testing. Vice versa, drivers are the calling programs which actually act as the higher modules, and they help us do the bottom to up approach testing of the integration testing. Now, if you see a tabular difference between the stub and the driver quickly. So stubs are of course used in the top to down approach. We have already seen it, and the drivers are used in the bottom to up approach. Stubs are called call programs, and drivers are called calling programs. We have already talked about it also. Now stubs are similar to modules of the software that are under development. Yes, in the entire process of development, they are not yet ready. So what we do, we use stubs. So they are the modules which are under development. Whereas the drivers are used to invoke the component that needs to be tested. Yes, because we already have these modules ready with us, lower modules, but we cannot test the entire flow because the higher modules are not ready. So basically these drivers are the components which needs to be tested. So if you think in a way, they are the modules which needs to be tested. So that's the difference of a definition also between stubs and drivers. Stubs are used in the unavailability of the low level modules. Absolutely. So far we have seen that. Whereas in the case of drivers, they are used in place of the high level modules, and in some situation also for the low level modules. So majorly the difference, this is a minor difference between the two pointers. Now stubs are taken into use to test feature and functionality of the modules, whereas driver is the main module of the entire testing. So in a way wherein stub will be helpful in testing the features of the flow, drivers are the main modules of the testing flow. There are a few more differences. So stubs are taken into consideration if testing of upper levels of the modules are done and the lower modules are still under development. So that's the only definitions we have been reading so far. And drivers are taken into concern if testing of the lower modules are done and upper modules are under developing process. So it's the same vice versa situation. We have seen that. And the last difference is also related to the definition, wherein stubs are used when the lower modules are missing or partially in the partially developed phase, and we want to test the main module. Whereas in the case of drivers, the higher modules are missing or partially developed, and we already have the lower modules ready with us. So that's the difference between stubs and driver. It revolves around the statement wherein stubs are the programs which act as the lower modules and drivers are the programs which act as the higher modules. So today we have seen what is unit testing, what is integration testing, and what are the different methodologies to do integration testing. So we have talked about Big Bang approach, we have talked about incremental approach. So in the incremental, we saw there are majorly three types of approaches. One is top to down, one is bottom to up, and the last one is sandwiched approach, which is the hybrid of top down and bottom to up. We saw that in these incremental approaches, we use two types of program. One is called stub and the other one is called driver, and how stub and driver are different from each other, how they are helpful in performing integration testing. We took an example of the banking application also, wherein we saw what are the higher modules, what are the lower modules, and how top to down approach and bottom to up approach are used while doing integration testing. So that's all for today. In the next session, we'll be learning more about testing. Thank you.